This is the present accepted form of the structure of the atom, in which the electrons revolve around the nucleus of the atom in fixed orbits or shells. So are these electrons distributed randomly? That is, can there be any number of electrons in any shell? Well, no. There's a definite pattern, a definite distribution of electrons around the nucleus, which is known as the electronic configuration of the atom. It's a definite arrangement of electrons around the nucleus of the atom. To get the electronic configuration, it follows a certain set of rules. These rules were given by two scientists, Bohr and Berry. The two scientists, they gave a set of rules, and these are known as Bohr and Berry scheme. So let's see what this scheme says. The first rule of the scheme is the maximum number of electrons in a particular shell is given by 2n square, and this n stands for the number of shell. That is, the first shell, it has n is equal to 1. So if we substitute this in the formula, we get 2 into 1 square, which is 2. The second shell has n is equal to 2. So if we substitute it in the formula, we get 8, 18, 32, and so on. So this means that the first shell can have maximum 2 electrons. The second shell can have maximum 8 electrons. The third shell can have maximum 18 electrons, and so on. So this is a helium nucleus. It has 2 protons and 2 neutrons. Now let's add electrons to this. So as we add electrons, observe what happens. So you see that this third electron that I added automatically moves to the second shell. Even if I try to add it in the first shell, we see that it occupies or it takes position in the second shell and not in the first shell. This is because by 2n square rule, we know that the first shell can accommodate a maximum of 2 electrons. So the third electron cannot be accommodated in the first shell, and so it takes position in the second shell. Similarly, if I add one more electron, it takes its position in the second shell and not in the first shell. So if you remember the names that are given to the shells, so the first shell is known as the K shell. It can have a maximum of 2 electrons. The second shell, known as the L shell, can have a maximum of 8 electrons. M shell can have 18, N 32, and so on. Let's move to the second rule. The second rule says that electrons are not accommodated in a given shell unless the inner shells are filled. That is, the electrons are filled in a stepwise manner. Let's see. Here we have a nucleus. So as we add electrons, the electrons first occupy the first shell, that is the K shell. According to Bohr, the energy of the shells is related to their size. So the first shell is smallest in size, so it has the lowest energy. Now when this shell gets filled, then the electrons are occupied in the second shell. So this shell, that is the L shell, has energy more than the first shell. So when this shell gets filled, then the electrons go to the next shell, that is the M shell, which has the highest energy out of these 3 shells. As the size of the shells increase, the energy of the shells also increase. So we see that the electrons are occupied in the shells in a stepwise manner. That is, first the K shell gets filled, then L, M, N, and so on. The third rule says that the maximum number of electrons that can be accommodated in the outermost orbit is 8. So the outermost orbit cannot have more than 8 electrons. So let's revise the 3 rules. So according to the first rule, the electrons are occupied in the shells following the rule 2n square. That is, the first shell can have a maximum of 2 electrons, second shell can have maximum 8 electrons, and so on. The second rule says that the shells are filled in stepwise manner. That is, the electrons first occupy the K shell, then L shell, and so on. The third rule says that the maximum number of electrons that can be accommodated in the outermost shell is 8. So the outermost shell cannot have more than 8 electrons. So let's see. Let's try to write the electronic configurations of a few atoms. So here we have oxygen. It has 8 electrons. So let's revise the rules. So according to the first rule, the electrons are occupied following the rule 2n square. So the first shell of oxygen, it can accommodate 2 electrons. Now oxygen has 8 electrons. So the first shell occupies 2 electrons, remaining 6 electrons go to the next shell. So this is for the K shell, this is for the L shell. Now since it has only 8 electrons, so we leave the other factors. The second rule says that shells are filled in stepwise manner. So the way we write the electronic configuration is, we first write the number of electrons that are occupied in the first shell, then we write a comma, then we write the number of electrons present in the next shell. Since it has only 2 shells, that is the 8 electrons can be accommodated in the 2 shells itself. So we enclose it within brackets. This is how we write the electronic configuration. And the third rule says that the maximum number of electrons in the outermost shell cannot be more than 8. So since we have only 6 electrons in the outermost shell, so it also obeys the third rule. So this is the electronic configuration of oxygen atom. So for oxygen, the electronic configuration is 2, 6. That is the first shell or the K shell has 2 electrons and the second shell or the L shell has 6 electrons. Similarly, if we have an atom, neon atom, it has 10 electrons. So the first shell can have 2 electrons and the remaining 8 electrons are present in the second shell, that is the L shell. Now let's take another example, sodium. It has 11 electrons. So from the first rule, we know that the first shell can have 2 electrons. Now sodium has 11 electrons. So the second shell can have 8 electrons. Remaining 1 electron, it goes to the third shell. So from rule 2, we know that the electrons, or they occupy shells in a stepwise manner. So how do we write it? We write the electrons in the first shell, followed by the second shell and the third shell. And then we enclose it within brackets. And we see again in this case, the number of electrons in the outermost shell is not more than 8. So it also obeys the third rule. So the electronic configuration of sodium is 281 and it's not 29. So we have to follow the 2n square rule in this. Similarly, another atom, argon atom, this has 18 electrons. So it also obeys the 2n square rule. So the first shell has 2 electrons. This is the K shell. L shell has 8 electrons. M shell has 8 electrons. So the electronic configuration for argon is 288. Let's take another example, calcium atom. It has 20 electrons. Let's see how it follows the rules. Okay, so according to the first rule, it should occupy the electrons based on the 2n square rule. So we have calcium, it has 20 electrons. So the first shell can accommodate 2 electrons, the second shell can accommodate 8 electrons, and the third shell can accommodate 18 electrons. We are left with 10 electrons. This means that the third shell can accommodate 10 electrons. Now, the second rule says that the shells are filled in stepwise manner. So, if we have to fill them, we get 2, 8 and 10. But now when we see the third rule, it says that the maximum number of electrons that can be accommodated in the outermost shell is 8. If you'll see here, there are 10 electrons in the outermost shell. So this is wrong. There cannot be more than 8 electrons in the outermost shell. The outermost shell can have only maximum number of 8 electrons. So how do we write the electronic configuration of calcium? We write 2, 8. Since this shell can have maximum 8 electrons, so we write 8. Remaining 2 electrons go to the last shell. So this is the electronic configuration of calcium. Remember, we do not write (2828). Why? Because this is wrong. When we are distributing these 10 electrons, we do not give the third shell 2 electrons and the last shell 8 electrons. The shells are filled in a stepwise manner. So when we are filling electrons, we first have to give 8 electrons to the third shell. The remaining number of electrons, they go to the last shell. So in this case, it has 10 electrons. So the third shell gets 8 electrons. Remaining 2 electrons go to the last shell. So this is the electronic configuration of calcium. It obeys the third rule, second rule and the first rule. That is why this arrangement, that is 2, 8, 10 is wrong, because it violates the third rule. So the electronic configuration of calcium is 2, 8, 8, 2. That is, the K shell has 2 electrons, L 8, M shell 8, N shell 2. So we never write 2, 8, 10. Because anytime you see the valence, the outermost shell having more than 8 electrons, this is wrong. So always keep in mind that the outermost shell cannot have more than 8 electrons. The magnesium atom consists of 12 electrons. What is the electronic configuration of magnesium? So again, let's recall the rules. The magnesium has 12 electrons. By the 2n square rule, the first shell can have 2 electrons, the second shell can have 8 electrons, remaining 2 electrons go to the last shell. The second rule says that the shells are filled in a stepwise manner. So we first fill the K shell, then the L shell, then the M shell, which has 2 electrons. So this is the electronic configuration. And this does not violate the third rule, which says that the maximum number of electrons that can be accommodated in the outermost shell is 8. We see that the outermost shell has 2 electrons, so it obeys all the rules. So this is the Bohr and Berry scheme for arranging the electrons in the shells.